Hello everyone, this is my English speaking practice and I'm working on coding problems. Today's problem is compare version numbers. Let's go. Given two version strings, version 1 and version 2, compare them. A version string consists of revisions separated by dots. The value of the revision is its integer conversion, ignoring leading zeros. To compare version strings, compare their revision values in left to right order. If one the version strings has fewer version, treat the missing revision value as 0. So return the following. If the version 1 is less than version 2, return -1. If the version 1 is greater than version 2, return 1. Otherwise, return 0. So let's see the example 1. Version 1 is 1.2 and version 2 is 1.10. In this case, 1, 2, and 1, 10. So 2 is less than 10. So version 1 is less than version 2. So we have to return -1. Okay. And okay. When version 1 is 1.01 and version 2 is 1.001, we'll return 0 because ignoring leading zeros, both 01 and 001 represent the same integer 1. And example 3. Version 1 is 1.0 and version 2 is 1.0.0.0. In this case, version 1 has less revision, which means every missing revision are treated as 0, 0, 0. So yeah, this is regarded as 1.0.0.0. And for constraints, the lengths of versions are from 1 to 500, and version strings contain digits and dots, and version 1 and version 2 are valid version numbers. All the given revisions in version 1 and version 2 can be stored in a 32-bit integer. Okay. Okay. Let's get started. Compare version. Is this difficult? The first idea that comes to my mind is to split by dots, and we can get the integers, and we can get a list of integers, so we just iterate through those integers at the same time and we compare it, and yeah, as long as they are the same, we going forward. But if the numbers are not the same, we can return -1 or 1 at the time. Yeah. So this is my simple solution, but is there any missing? Is there any consideration I have to do? So let me code it. So version 1 be version 1 split by dot, and version 2 list of integers can be made from this function, and we can get the length of versions, but the lengths are not the same, might be not the same, so we compare it and choose the maximum one, because we can make up zeros if it doesn't exist. So we iterate through the list of integers, version integers, and it is range n. Yeah, there must be one element, so yeah. We can we can treat the missing revision values as 0. So the code is like this, and we compare the compare two values, and if they are not the same, we just return it, and we iterate. After we iterate through the lists, and we haven't returned the answer, so it means the version is same, all revision values were the same, so we return 0. Oh, I see. Great. Wow. I didn't think this is the expected solution, but a bit 100%, so it seems good. Because yesterday I spent a lot of time to solve the problem, and yeah, it was about bucket salt or something like that, and I was so confused. It was so difficult, and I spent a lot of time, and I ended up with seeing solutions. Yeah, and I thought how difficult it is. Yeah, so that's why I didn't expect this answer would be the best. Yeah. Because this is the same as a solution, intuitive solutions. Yeah, so the time complexity is n, because we visit every revision values at once, and the space complexity is n. We split it by dot, and we get the list of integers. So we need a linear space, and that's it. Okay, go to next. Fraction to recurring decimal. Given two integers representing the numerator and denominator of a fraction, return the fraction in string format. If the fractional part is repeating, enclose the repeating part in parentheses. If multiple answers are possible, return any of them. It is guaranteed that the length of answer string is less than 10 power 4 for all the given inputs. Note that if the fraction can be represented as a finite length string, you must return it. So numerator and denominator, okay. So it means division, and the answer is quote quota quotes quotient
Quotient remainder.
quotient remainder quotient remainder. Yep. So quotient, we have to return quotient and it might be infinite repeating. Yeah, I understand. And the numerator and denominator is fit in 32 bits integer, and denominator is not 0. Okay. This is about mathematical. Mathematical we cannot use divide function. That is I have no idea. Let me think. For example, we have 1 and 2. 1 and 2, so 0 because when we compare 1 and 2, the 2 cannot be in the 1, within the 1, so it's 0. Okay, and when we move on to the next, we can multiply 10 to numerator, and we get 10, and Yeah, and we count how many 2's exists in the 10, and that is, yeah, just division, and the answer is 5, so we can get 5. And this formula, this remainder is 0, so we can finish it, and we return 0.5. And how about this? No, this is so simple, we just return 2. Okay, how about this? 0, 40, still 0, 400. We can put 332 once. Okay, and the important thing is here, the remaining we have to return remaining 67, and we have to divide, we have to multiply 10, so it's like this, and we can calculate it, the how many 333s is in the 670. The answer is 2. Okay, and the remaining is 666, so remaining is 4. And we have met 4. Yeah, we get 4 again, so it must be circle, so we can not 4, it's 40, so maybe this is the answer when the numerator is 40, so we can move on to this, so we can identify the repeat. We can identify the part for part to repeat. Okay, this is the I think this is the main logic. And for negatives, I wanna handle sign at first, and we're gonna implement it as the number value is positive, all positive. Yeah, in order to do that, we handle sign at first and make the number value positive. Okay, yeah, this is my plan. So the first step and yep. So if the multiplication is positive, it means their signature is the same, so the quotient would be also not also when they are the same, the quotient would be positive, so the sign is positive. Oh wait, we have to yeah, and we have to make the number value positive, so we handle signs and values at first. Okay, and the numerator might be 0. In this case, the fraction would be 0. That's it. And we are gonna implement this. Denominator, yeah. Yep, and the quotient, we get the quotient and remainder get this function. by this function, and numerator denominator. Okay, and we have to we have to store it, and yep, we have to store it, and we have to manage their index, because if it's shown before, there must be repetition. So yeah, so we can update the mapping dictionary, like the quotient for the key, and length. The current maximum index is the corresponding index. Okay. If there is already value that equals to quotient, we can find the cycle. So and we return string. Okay, so head part would be numbers, and we can use slice numbers mapping q until this index, and the repeated part is like this. Okay, we have to in this case, head is like this and 0, 1. This is head of head, okay? Because we have to put the dot and this is just pass the function. So we do the same for this part. Just convert it to string. Yep. And return head over head, and we have to join it. Okay. And add a parenthesis, repeat it. End of parenthesis, yeah, parenthesis. Okay. If there is no cycle, the numerator is next to numerator. 10 times remainder, yeah. Oh wait, oh yeah, it's good, and yeah, if the remainder is 0, the numerator is also 0, so we can break this while loop and we have to return but basically it be separated head, its left part from the dot and the right part fraction. Fraction would be, yep, be made by the numbers after second one. After first one, after second one. Type object is not nums. I see. Yeah. If there is two or more elements, if there is two or more elements, we have to put a dot. So the first element is the how to say integer, decimal. Yeah, the first element is the integer part, and the numbers after first one would be the decimal part. If there is one answer, one element, that is just integer. So that's it. What? A function iterable. Okay. Function iterable. We have to swap function iterable. Oh, wait. Function iterable. Function iterable. Let's go. Wrong answer. 0 point. Oh, I see. I see. So if it's a first, we don't. We shouldn't update the mapping because that is not included in the cycle, decimal cycle, recurring decimals. So like this, we skip this process for the first loop. It's like this, like this, like this. Yep. Yep, yep, yep. Great. Submit. Wrong. Oh my gosh, I totally forget this. So totally forget. Really? Zero, zero, zero. Oh, I missed something. Something important. Zero, zero. Okay. Oh, I see. So it must be. Yeah, it must be to check quotient and remainder, right? Quotient and remainder. It's actually like this. Yeah. Because when we calculate this one, it's 10 divided by 333, and next it can and the quotient is 0 and the remaining is remaining is always denominator, because I'm confused. Zero one. Ah, 010, 0100. Yeah, makes sense. So remaining would be the numerator. So yeah, we have to check both of them. It affects the repeated part. Yeah, just checking quotient is not enough. We have to check both of them. Yeah, if they are the same, it's gonna be making same cycle. Recurring decimals. Yep. So let's go. Still wrong answer. Okay, we have to return string. Got it. But this is the first test answer. Almost the same, I think. Almost same. For the first time in a while. Today I'm gonna write some comments in English for the first time in a while. For the first time in a while. Okay? Yeah, it's time to learn English phrases, and we'll have it reviewed. Okay? So, at first, we handle sign and make the values positive. The sign will be used when we return the answer. And if numerator is 0, the answer must be 0. Don't forget to convert it into string. Okay. This is an example when there is recurring decimals. Okay, and yeah, here is the main logic. We prepare two data structure to keep track of calculation results. Mapping has quotient, remainder for the key, and index for the value. Nums stores the result, calculation result for each digit. For each digit, a mapping has pair, quotient and remainder for the key, and index of nums for the value. And as long as numerator is greater than 0, we divide the numerator by denominator. here is the example. Zero and 4. So we append 0 to nums. Okay. And the numerator will be multiplied by 10. So the calculation result is like this. The quotient is still 0, and the remainder is 40, and the nums is 0, 0. And for the next loop, remainder times 10, it's gonna be 400. So we can put 333 in the 400, and the remainder is 67. And the nums is 0, 0. We can append 1 to it. And the next step is like this. So we can put 2 333s, and the remainder would be 4. Okay. Zero, 0, 1, 2. Okay. And yeah, there's 4. So the next calculation is like this. But we have found we have already the result of 40 divided by 333, and the index is 1. So we can find so we can find recurring decimals like this, and we append quotient to the nums, and but if not, the result might be the starting point of recurring decimals, so we have to record it. We append the value just now. The index to record is this. Okay. Yep. This part is already explained, but how can I explain this? Yeah, it's a natural process for division. So I think I don't need to explain this part. It's process of division, and yeah, we learned it in elementary school. So I think this is okay. And for this part, when we which means there's recurring decimals, so we can return the answer. Yeah. Being careful to add parentheses. Being careful to add there's no recurring decimals, so greater than 1. Okay. Okay. Here is your code rewritten in your preferred spoken commentary style, like you're walking your audience through it on stream. It keeps the structure and logic identical, but the comments now sound more natural, casual, and clear for someone listening in real time. So let's think about what's going on here. We are basically trying to divide two integers, and if the result is repeating decimal, we need to wrap that part in parentheses. The trick is to detect when the decimal part starts repeating. First, let's handle the sign and simplify the numbers. If the numerator is 0, the result is just 0, and we will add the sign at the very end. Okay, now let's move on the main part. We will keep track of all the quotient digit in a list, and we will also remember where each quotient remainder pair appeared. If we ever see the same pair again, that means the decimals are repeating. As long as we still have remainder left, we will keep dividing. Let's think through an example. And now we've seen 04 before, and that's where it repeats. If we've already seen this quotient and remainder pair, that means the decimal part is starting to loop. Otherwise, we record this digit. If we already have at least one decimal digit, we store this QR pair with its index, so we can detect a repeat later and move on to the next digit, multiply the remainder by 10. If we finish the loop normally, that means it terminates cleanly, no repetition. Now let's format the output. There's a fractional part, otherwise it's just an integer. Oh, good. Let me see. We handle edge cases. ChatGPT what looking at another one. At first, we handle sign and make the body positive. The sign will be used when we return the answer. First, handle the sign and make both numbers positive. We will apply the sign when returning the final result. If numerator is 0, the answer must be 0. Don't forget to convert it into string. If the numerator is 0, the result is obviously 0. This sign is added later. We will add the sign to the final string later. Okay? This is an example when there is a recurring decimals. Recurring decimals. Oh, not the. This is an example of a fraction that produces recurring decimals. Of a fraction that okay, here is the main logic. We prepare two data structures to keep track of calculation results. Nums stores calculation result for each digit. Mapping has pair for the key and the index of nums for the value. Here is the main logic. We'll use two data structures to keep track of the calculation. Nums stores a quotient for each digit, and mapping stores a pair quotient remainder as a key and the index in nums as a value. For each digit. I see. Meaning fine, slightly repetitive. Okay. While the numerator is greater than 0, keep dividing it by the denominator. Yep. Minor grammar fixes. When we see the same QR pair again, it means the decimals start repeating. Okay. When we can find the pair in mapping, it means there is a recurring decimals. So we can return the answer being careful to add parentheses. There is a recurring decimals. There are recurring decimals. There are. Okay. If we find the same QR pair in the mapping, it means the decimals start repeating. So we build the result string, adding parentheses around the repeating part. And this expression is useful anyway. So we build the result string, adding parentheses around the repeating part. technically correct. Skip the first loop. After that, record QR since it might mark the start of since it might mark the start of mark the start of repeating cycle. Fine. When we reach this point, there is no recurring decimals, and if the length of numbers is greater than the fraction part exists, there is a fraction part. Otherwise, we just return integer part. Otherwise, we just return the integer part. Your comments are technically very accurate and show an impressive understanding of the logic. Main improvements: add missing articles, fix plural forms, fix plural forms, smooth out stiff phrases. There are optionally make transition flow more naturally. First, next, finally. Okay. Would you like me to write all the comment in a fluent spoken style version, like Dave explaining the logic to someone while coding? Not needed. But my English comments are improving. Yep. So it's time to finish. I solved 76. Okay. And my the goal this week is to solve until 85. So 9 problems remaining, but today is Wednesday, so I have Thursday, Friday, Saturday. I have 3 days. So 3 problem per day. Yep. Okay. So finish this stream.